The world faces a daunting challenge. Our growing population and expanding industries demand more energy than ever before. We need more energy, but we must produce it cleanly. Renewable sources like solar, wind, and hydroelectric power are part of the solution. Our climate is changing, and fossil fuels are a major culprit. The burning of coal, oil, and gas releases harmful greenhouse gases into the atmosphere. Nuclear power offers a tempting solution. It has the potential to provide large amounts of energy without the carbon emissions. It generates electricity without emitting greenhouse gases, making it an attractive option in the fight against climate change. But it also comes with significant risks. The management of radioactive waste and the potential for catastrophic accidents are major concerns. Accidents, waste disposal, and the potential for proliferation of nuclear weapons are all serious concerns. The disasters at Chernobyl and Fukushima are stark reminders of these dangers. For decades, nuclear power has been both a promise and a peril. It has sparked debates and divided opinions worldwide. It has provided us with a reliable source of electricity, free from the pollution of coal-fired power plants. Yet the risks cannot be ignored. The disasters at Chernobyl and Fukushima serve as stark reminders of the potential for catastrophic accidents. These events have left lasting scars on our collective memory. The future of nuclear energy hangs in the balance. Advances in technology offer hope for safer, more efficient reactors. Technological advancements offer the potential for safer, more efficient reactors. Innovations in reactor design and safety protocols are promising, but public perception remains wary and the echoes of past disasters linger. The fear of another catastrophe looms large in the public consciousness. The decisions we make about nuclear power in the coming years will have profound consequences for our planet and generations to come. It is a choice that will shape our future. In the spring of 1986, the world watched in horror as disaster unfolded at the Chernobyl nuclear power plant. The event would become one of the most infamous nuclear accidents in history, forever changing the way we view nuclear energy. A flawed reactor design and human error combined to create a perfect storm. The plant's operators were conducting a safety test that went catastrophically wrong. The result was a catastrophic explosion and fire that released a plume of radioactive material into the atmosphere. This radioactive cloud spread over much of Europe, contaminating land and water. The immediate impact was devastating. Buildings were destroyed and the reactor was left in ruins. Dozens of plant workers and first responders died from acute radiation sickness. These brave individuals faced lethal doses of radiation in their efforts to contain the disaster. Thousands more in the surrounding area were exposed to dangerous levels of radiation, leading to long-term health problems. The evacuation of nearby towns was chaotic and fraught with fear. The town of Pripyat, once home to the plant's workers, became a ghost town. Its residents were forced to leave behind their homes and belongings, never to return. The Chernobyl disaster sent shockwaves far beyond the borders of Ukraine. It became a global symbol of the potential dangers of nuclear power. It shattered the illusion of nuclear safety and cast a long shadow over the future of nuclear power. Public trust in nuclear energy was deeply shaken. Governments around the world scrambled to reassess the safety of their own reactors and reassure a fearful public. New regulations and safety measures were implemented in an attempt to prevent another disaster of this magnitude. The impact of Chernobyl was not limited to the immediate vicinity of the disaster. The radioactive cloud traveled across Europe, contaminating crops and livestock. Countries as far away as Sweden and the United Kingdom detected elevated levels of radiation. The economic consequences were also far-reaching. The Chernobyl disaster cost billions of dollars in cleanup and decontamination efforts. It also dealt a major blow to the global nuclear industry. Public confidence in nuclear power plummeted, leading to cancellations of planned reactor projects and a slowdown in the industry's growth. Chernobyl taught us a harsh lesson. Nuclear accidents do not respect national borders. The interconnectedness of our world means that a nuclear disaster anywhere is a threat to us all. It highlighted the need for international cooperation on nuclear safety standards and emergency response protocols. China is rapidly emerging as a global leader in nuclear power. Faced with soaring energy demands and a desire to reduce its reliance on coal, China has embarked on an ambitious program to expand its nuclear energy capacity. It is building new reactors at a breakneck pace and investing heavily in nuclear research and development. But China's nuclear ambitions extend far beyond its own borders. It sees nuclear energy as a key component of its Belt and Road Initiative, a massive infrastructure project aimed at expanding China's economic and geopolitical influence across Asia, Africa, and beyond. China is actively exporting its nuclear technology to other countries, offering attractive financing packages and turnkey solutions. This has raised concerns among some Western nations, who see China's nuclear exports as a challenge to their own geopolitical interests. Section 5. Atoms for peace or power plays. The geopolitics of nuclear energy. This topic delves into the intricate relationship between nuclear power and global politics. Nuclear energy has always been intertwined with geopolitics, influencing and being influenced by the global power structure. The development of nuclear weapons during the Cold War cast a long shadow over the peaceful use of atomic energy, creating a complex legacy. The ability to harness the power of the atom became a symbol of national prestige and a bargaining chip in international relations affecting diplomatic strategies. Today, the geopolitical landscape is shifting, with new players emerging and old alliances evolving. The rise of China as a nuclear power is reshaping the balance of power in the world, challenging the dominance of established nuclear nations. China's nuclear exports are giving it leverage in regions traditionally dominated by Western powers, altering the geopolitical landscape. This has led to increased competition for influence and access to resources as countries vie for technological and strategic advantages. The future of nuclear energy will be shaped by these geopolitical dynamics, with potential for both cooperation and conflict. International cooperation will be essential to ensure that nuclear energy is used safely and responsibly, fostering global stability, but the pursuit of national interests could undermine these efforts, increasing the risk of proliferation and conflict and posing significant challenges to global peace. Section 6. Shrinking the reactor, expanding the possibilities, the rise of SMRs. In the quest for safer and more flexible nuclear energy, a new generation of reactors is emerging, small modular reactors, or SMRs. Unlike traditional large-scale reactors, SMRs are designed to be smaller, simpler, and more versatile. SMRs offer several potential advantages over conventional reactors. Their smaller size makes them easier and cheaper to build. They can be deployed in a wider range of locations, including areas with limited grid infrastructure. And their modular design allows for greater flexibility in operation and maintenance. Proponents of SMRs argue that they could revolutionize the nuclear industry, making it more accessible to developing countries and reducing the financial risks associated with large-scale nuclear projects. But critics caution that SMRs are still an unproven technology and that their safety and economic viability remain to be seen. Section 7. Safety by design. Can we outsmart nuclear's risks? The spectre of nuclear accidents continues to haunt the industry. The disasters at Chernobyl and Fukushima demonstrated the devastating consequences of design flaws and human error. In the wake of these tragedies, there has been a renewed focus on nuclear safety. Engineers and scientists are working to develop new reactor designs that are inherently safer than their predecessors. Passive safety systems, which rely on natural forces like gravity and convection rather than human intervention, are becoming increasingly common. Advanced materials and computer modeling are being used to improve reactor reliability and prevent accidents. These technological advancements offer the potential to make nuclear power safer than ever before, but technology alone cannot eliminate all risks. Human error, natural disasters, and the potential for sabotage or terrorism remain ever-present threats. Section 8. The nuclear crossroads, balancing hope and caution. Nuclear energy stands at a crossroads. It has the potential to play a significant role in addressing climate change and meeting the world's growing energy needs. But it also carries significant risks that cannot be ignored. The decision of whether or not to embrace nuclear power is a complex one, fraught with ethical, environmental, and geopolitical considerations. There are no easy answers. Each country must weigh the potential benefits against the potential risks, taking into account its own unique circumstances and priorities. The future of nuclear energy will depend on our ability to learn from the mistakes of the past and to embrace new technologies that can enhance safety and reliability. It will also require a commitment to transparency, international cooperation, and a shared sense of responsibility for the safe and peaceful use of atomic energy. Section 9. Our energy destiny, a shared responsibility. The choices we make about nuclear energy will have profound consequences for generations to come. It's not just about keeping the lights on. It's about protecting our planet, preventing climate change, and ensuring a sustainable future for all. We can't afford to be driven by fear alone, nor can we afford to be reckless with such powerful technology. This is a conversation that needs everyone at the table. Scientists, policymakers, businesses, and everyday citizens all have a role to play. The future of energy isn't predetermined, it's something we're building together right now. It's a future where, hopefully, human ingenuity and respect for our planet can guide us towards a brighter, more sustainable tomorrow.